record on this computer. All right, welcome to Going the Distance, our final Going the Distance faculty instructor seminar that we have scheduled with the amazing Al Gasiewski. Let me first just preface this by saying my name is William, and these have been a summer instructor-led discussion series around pedagogy, online and remote. They've all opened up some wonderful ideas, and the common theme has been to think about this moment that we are in as an opportunity for reflection on how we teach. Obviously, we'd all rather be going into a semester that didn't involve mandated social distancing. However, this is a powerful moment to think about teaching, the current state of the art of teaching, and the future of teaching at the University of Colorado Boulder. So I mentioned this is our last Going the Distance scheduled instructor meeting. And I want to put forth to anyone watching this video and to the people in the audience here who are signed on to the Zoom discussion, that we should think about what we want to move forward with. So please take a moment and write me and tell me at this moment, what do you need to move ahead? I am currently focused on scheduling some more technical discussions around Zoom and MediaSite, the campus's new recording mode that's hosted by OIT. I'm going to schedule those up and put them on the Going the Distance website. I think that they're going to be very useful. However, I invite everyone to write me and tell me what you need going forward. So with no further ado, I want to introduce Al Gasiewski. Al is a specialist in remote sensing of atmospheric and oceanic processes. He works largely in antenna design and is actively engaged in the development of surface.
I gotta focus on this. I have to focus on this.
Oh, Julie, you do have to focus on this.
So sorry.
That's all right. I'm going to just put you on mute there. Now, back to Al's CV. He is actively engaged in the development of surface-based airborne and spaceborne remote sensing systems. I was in Kuwait City discussing our aerospace design efforts at the University of Colorado at Boulder, and I discovered that Al is ahead of me, and that he has embarked on a very exciting collaboration with the Kuwait government and the Kuwait University to develop some wonderful satellite devices. So when I think of Al, I think not only of someone who teaches in our own department and who develops remote sensing, but really an internationalist, someone who's reaching across the globe to extend our connection around learning and around engineering sciences. So I'm so impressed by Al. When I first started this Going the Distance, Al really leapt to the challenge and suggested that he's been teaching, since he's been teaching remotely and online for years now, that he might provide a discussion about revising course materials and developing the course as really a higher level of execution than simply prepping lectures, but really thinking of the course and the larger teaching portfolio for online delivery. So with no further ado, let me turn this hour over to Al and thank him really, really earnestly for delivering this. So thank you, Al. I'll pipe down now and I'll let you take it.
Thank you, William. I hope I can live up to that. I do appreciate one comment you made about thinking ahead and taking the opportunity, seizing the opportunity, because I really do think that this is not just a requirement that we change because of the social conditions around the globe, but it's an opportunity for us to reinvest in education, maybe in a different way. And what I'll try to do today is, based on my experience in delivering online material, I'll try to give you my little tips and techniques. So let's see. The first tip and technique is to learn how to advance the slides. There we go. Just a little bit of background. I started teaching remotely back at Georgia Tech in 1993. I taught a course called Instrumentation for Test and Evaluation. And at the time, most of the faculty thought, well, what are you doing this for, Al? It seems like you're just going to be running a sort of a community college effort, sort of a training effort for people. This isn't really academics. Well, I didn't know really how to respond to that, so I just went ahead and did it. I developed some curriculum around how to make measurements with instrumentation in electrical engineering. And I put together a series of lectures. I started by actually team teaching the course first time, and then later on took it on entirely. And back then we used VHS videotapes. How many remember what a VHS videotape is? A couple people raising their hand here showing their age. And it was sent using a new delivery service called Federal Express. Hear those guys? Well, it was a bit cumbersome. And so in the intervening time, I came out to Boulder, I began teaching at CU, and the first thing I did when I started teaching at CU in 2006 is I put all of my graduate courses one by one onto the video format, which allowed me to teach remotely. So I've got now 5 courses that are fully what I would call compliant with the standards I like and allow me to teach them remotely. The slide sets are well established. The curriculum is well established. And where the curriculum fits is also well established. In other words, how these courses mesh together. One feeds into the other, to the other, to the other. These 3 graduate courses in particular, 5244, 54, and 64. These all feed into one another and they allow students to get into the cycle of taking remote sensing courses. Last spring, I had the opportunity to turn my undergraduate circuits course, which is usually about 80, 85 students, into a complete video offering. And I started doing that in January. I think it was January 11th, first day of class. I had to be on travel that day for the first day of a lecture of 85 students. So I presented remotely very much like what I'm doing right now. And it turns out that when I came back the next day and asked the students whether they liked it, they all said, "This is great. Let's do this for the semester." And then I thought to myself, oh no, I've got to take all of my lecture notes and turn them now into slides. I started doing that. And at the end of January, I realized with the COVID numbers creeping upwards in China that maybe this was more than an onerous chore I just had to do for the students. Maybe it was a real investment. It turned out to be. Now, I'm also developing another MOOC. We won't go into that though, but what I really want to gear a lot of the lecture around is how do we put quality into a remote course? How do we even define the word quality? Everybody knows what quality is. How do you put a definition on it? Well, it's a property which someone wants. That's probably the best definition of it. The problem in course development is that quality is readily apparent in student successes, usually after the course is completed, sometimes years after the course is completed. I look back at what were the quality courses I took when I was an undergraduate, and I don't think I really even knew which ones they were until a few years afterwards. And then all of a sudden, the things that I learned in those courses kept popping up over and over and over, and the course almost unfolded throughout my career rather than something that just happened during the 3 months that I was sitting in the classroom. Why is this the case? Well, a valuable course, I think, one that contains the essence of quality, it's necessarily both complex and challenging. Complex, but in a way where if you present it properly, you're able to maneuver the students' thinking through the complexities. Challenging because frankly, if it's not challenging and you don't walk away a little bit humbled by it, it's not a course that's worth your money, frankly. Now, this actually flies in the face of our FCQ system, which rates faculty at the end of the course when students are least capable of judging quality, in my opinion. But that's an opinion only, and I won't spend any more time talking about that here. Instead, I'll posit that a quality course provides an experience that is complex, challenging, and it changes a student. A student should not think the same way after taking a quality course. I mean, think the same way about the subject material. And that's the way I try to construct my courses, so that the students walk away and they just think differently. It has some bearing to symphonic quality and complexity. Now, I'm out on a little bit of a limb here as an engineering professor, speaking about something that really belongs probably in a course in philosophy. But I could ask the question, why do some symphonies endure? What do they exhibit? What are their common features? And I would argue that their common features are a deep complexity, but a uniform balance, a ring of truth throughout each movement, and precision in composition. Now, this is the Boulder Philharmonic up in the corner over here. I wish we'd be able to go see them this year, and it looks like we're not going to be able to. But I've been going to the Boulder Phil now, my wife and I, for the past, let's see, it's about 25 years almost. And we've really appreciated a lot of the symphonies. There's a guy who composed one of them that we hear every once in a while. You probably can figure out who that is. Once you start humming a bar of his Ninth Symphony, you can almost hum the whole thing. And that's because of this complexity and uniform balance and ring of truth through each movement and precision that is embodied in that composition. Now, that's not the only one that I think you can start humming a bar of and be able to hum the whole thing. There are a lot of them. And this can also be said for a lot of enduring popular music, even classic and modern literature. They all have the same attributes. We'll also test each other's age here and see if we can figure out who that very popular female singer is. How does this notion of symphonic quality and complexity apply to our development of online course material, or online courses, or just courses in general? Well, I'm not going to say I have a formula that tells you the answer to that, but I will show you how I put together a course that tries to balance it and make it complex and allow precision throughout. I'm not going to say that I ever even achieved that goal. I'll just tell you that's what I strive to do all the time. And each time you approach a course and reteach it, I keep striving again to do that. And eventually, I think that what comes out of it is a pretty refined construct. So this happens to be the first part of the symphony. And that is the set of movements. Each lecture, in some sense, is a movement. Unlike in a classical symphony, you might only have 4 or 5 movements. Here we've got 30 of them or 45 of them, depending upon just how many lectures you're giving throughout the semester. And each one has got to have its own complexity and connect to the other ones so that the other ones build on the previous one, and so that the themes that are being developed in these movements continue to pop up later on in the semester, so that by the time you're done, Circuits 2 is not just, well, yeah, I just suffered through that course, but it's rather an experience such that when one is presented with a circuit problem, it's going to just ring bells. It's going to achieve that, yeah, I've heard that bar before, and now I can hum through the whole thing if I want. So this is what I first off do. I make sure that I've got that balance, that complexity, that connection throughout all the lectures in the course. And the first time you teach a course, it's rare that this kind of a layout is going to hold. It might hold for the first month, month and a half. Once you get into the last month of the semester, though, you can kind of expect that maybe your symphony is going to need some revision. That's okay. The next time you play this symphony, you're going to be able to revise it. And that's what I always keep doing as well. The reinvestment aspect of this is important. This is a course that I've taught now, let's see, this is the 4th time, and it was the first time it was put onto video, but this outline evolved. I also, of course, will offer that I'm standing on the shoulders of giants, and I started with a course that it was already pretty well outlined with a great textbook. So I didn't have to worry about that aspect of the problem. So here we have it. That's pretty much the set of lectures for this course, and it brings us all the way to the final exam. And I make this available to the students on day 1 so that they can see what's coming up, so that they can keep track of when homeworks are due. Sometimes it changes a little bit too, so we have to be flexible as well. Now, that's the overall structure of the semester. I'm going to now drill down into one of the movements, one of the lectures, and show you how I put that together. And the way I like to see it, I like to see it in some ways presented in a fashion that I used to like when I was an undergraduate. I recall that there were a lot of great courses I took that really had that complexity, that balance, that theme throughout the entire semester. And in some sense, that's what I strive for in each lecture, sort of to copy the experience that I used to appreciate when I was an undergraduate. So I'm going to show you an example lecture, every slide of it copied slide for slide, and then I'm going to do it in about 5 minutes rather than 45 minutes or 50 minutes. So please bear with me. Please do not try to understand all of the equations and what they mean. Rather, just try to appreciate whatever balance and precision and complexity is present in the slides. I think that's really the more important thing. So here's an example lecture. Top of the hour, 15 seconds before the top of the hour, this is the slide that pops up. This is the lecture number, the date, and it is being recorded, the time, etc., etc. And the first thing I do is I welcome everyone. And these days, I welcome them and hope that they are all safe and healthy. Welcome to ECE and 2260 Circuits as Systems, lecture number 28. Now, the first thing I do is I don't go right into material. Instead, I back off and I try to provide the best teaser I can for why we're studying today's topics. And so I always have a real world application slide. Something that very, how you say, qualitatively connects what we're studying in the lecture to a real world application. And in this case, in circuits, the application for that particular lecture, this particular lecture, was public address systems. Of course, we take public address systems for granted. There's a lot of electronics involved in public address systems. There's a lot of physics in the microphones, in the speakers, in the feedback mechanisms. In fact, there's a lot of systems engineering in the feedback mechanisms. So I motivate that in no more than about 2 minutes. And I try to illustrate why we are studying what we're studying. Then, after that little teaser, we get into the details. First of all, I spend a couple of minutes talking about course administration, making sure that people are all comfortable with the homework due date, for example. Make sure they all know about the homework. Make sure they know how to submit it, etc., etc. This is the administration section, and it usually lasts no more than about 2 minutes. I might have 1 slide, I might have 2 slides. In this case, because of this lecture being presented after our pandemic outbreak, I always had a slide on COVID planning. Now, this is not technical, and it took away typically about a minute of the course, talking about a public issue, a societal issue, in fact, a global societal issue. And I really got good feedback from the students because they realized that I'm looking out for them in some sense. I'm not just here to run through material, so to speak, but I want to make sure that on a daily basis, to the best of my knowledge, that they understood just what we were getting into. And remember, at the start of the pandemic, nobody knew what we were really getting into. So anytime that you could present some reasonable, constructive comments on the societal situation, I think it was very valuable. Now, we start getting into the material. I remind them what we talked about in the last lecture, which is right off of our semester-long schedule of lectures. I remind them of our reading assignments. I then tell them what we're going to talk about today. We're going to continue talking about transducers. We're then going to talk about microphones, acoustic feedback, and stability. And there's our reading for today. Now, this is sort of like just the intro. This is the orchestra warming up, basically. Now we get into the material. So, I'll show you the way I like to put together slides. I like to have these little blue backgrounds that allow for transitions. And this transition slide is very important. It allows people to breathe. During a 50-minute lecture where you are intensively presenting equations and graphs, et cetera, you do need opportunities to breathe. So you'll see these transition slides fairly often. Right after the transition slide, then we go into the engineering issues. In this case, this was a little study of loudspeakers. And we needed to study the physics of loudspeakers. We needed to talk about the various forces on the cone of the loudspeaker, the mass of the cone, and how the sum of those forces was equal to the acceleration experienced by that cone, how Newton's laws, in other words, come into play. And we needed to have a clean diagram. The diagrams I find that I need simply do not exist. It's rare that I will go to any sites on the web, any textbooks, even the textbook I'm using for the course, and find the diagram that I need to explain the material properly. So these diagrams, over the years, they all originate out of my own thinking about the material. And I try to make them simple, I try to make them clean. I also try to define all of my mathematical variables so that there is nothing left to chance. So that later on in any of the slides, we don't have a symbol coming up like A sub C where it hasn't been defined. Now, once we start considering this system, then we can start talking about it in a little more detail. We can start using equations. Now, I have equations as the language of the course. Now, this is an engineering curriculum. It certainly wouldn't be the case in many other different disciplines, but in engineering, if we're not speaking in equations, we're really not communicating very precisely. This is the quantitative way we communicate. It also happens to be the way we solve problems. So my students on day one are immersed in equations, and throughout the course, this is the way we speak. We define our various forces, for example, on this loudspeaker in terms of these other quantities. I also am very particular about fonts and text colors. All of the text that's used in sentences, whether these are full sentences or whether these are phrases, are in Times New Roman, nothing else. There are only 2 colors to the fonts that are used. Every once in a while, I'll pop in a 3rd color, but it's only for emphasis. And every equation is in italicized font, whether the letters are Western or Greek. And this is something that I adhere to religiously throughout the composition. This is what I mean by the precision in the composition. Yeah, it's kind of hard to do. I do have a little technique that works well, though. I set up all of my equations separately within a LaTeX environment. I then print the equations. I copy the equations that are printed and paste them into these slides. I don't let Microsoft influence what my equations look like. Thank you, Lillian. I really admire Bill Gates in a lot of ways, but one of the things I think he really made a mistake on is the equation editor in Word, circa early 1990s. But we'll let that slip for now. Now, I try to use graphs, but I also try to make sure these graphs are labeled, and labeled with really large fonts and clear fonts, and features in them pointed out. If the feature is important, point it out. If the feature is not important, don't bother. These graphs, sometimes they take me an extra half an hour just to produce from the concept, even if it's a simple equation. It's worthwhile doing because it gets the message across cleanly. Cartoons are great. The right level of detail is needed. Sometimes you don't need the real guts of a loudspeaker, for example, and the inductances and the interwinding capacitances and the mass. You just want a little cartoon symbol. And so we introduce them as we need to. Circuits, I have yet to find a good drawing package, and so I draw all of my circuits carefully in PowerPoint, and I've developed a technique. I'd be very happy offline if anybody wants to know how to draw circuits. You may have different disciplines, so circuits may not be relevant. But develop a technique for drawing in your field that works and stick with it. Whether it happens to be in PowerPoint or in some other package, make sure you're comfortable with it. Make sure it's got that precision. Learn it well, stick with it. It's a good investment. Hopefully the company that makes the software won't go out of business in 2 years. And in some sense, I am lucky with Microsoft in that regard. PowerPoint has served me for well over 20 years now, 25 years. Now, I don't want to dwell on every one of these and teach you all about loudspeakers, so I'm going to try to go ahead. And I want to point out that the variables that I use all hail back to the early part of the course. I do not switch variable names throughout the course. I keep using those same names so that the symphonic movement from the first few lectures, and the symphonic flow rather, is maintained. I'm just going to keep going over here. A transition slide. Now we break. We're going to talk about microphones. I always talk about the history a little bit too when I go into a new section. History of microphones is rather interesting. They go back to Alexander Graham Bell, who really invented it at about the same time as another fellow named Gray. And I won't bore you with the details, but I do try to liven things up with a little bit of history. It puts the course into context. But of course, since it's an engineering course, we've got to go into the physics immediately. We do so similarly with real nice clean cartoons. Sometimes these take a while to produce. And I want to show you something that I use very often too. It's called the implication arrow. It's this little blue arrow. You might want to draw it a little bit differently. I like to draw it just plainly and clearly. It means that everything before that arrow implies that this is the case. And that implies that this is the case. And then finally, I sparingly use the red box to tell you, hey, this is an important equation or an important conclusion. And I'm going to start skipping ahead now because I want to get to the end of things in this lecture. And I want to show you one of the graphics I've developed. That for this particular lecture, it actually took me about a whole day to develop. On a Saturday too, I point out. But it was worth it because it really brought together a lot of key issues regarding feedback in public address systems. There's a speaker, there's an amplifier. Oops, here's a microphone, I should say. This is a speaking person. That's a microphone, that's an amplifier, and this is a loudspeaker. There's the audience. And then, of course, we all know this effect. There's feedback to the microphone, and it causes the howl, and everybody in the audience gets upset because there's this howling sound. And the technician has to go turn the volume down. Well, we wanted to understand that. Very important system control aspect in systems. So we began modeling the entire system with just what we learned earlier regarding microphones, speakers, amplifiers. Put together the transfer function. There's the whole transfer function now, from the talker to the listener. And now we add in the feedback. People think that this is all you need to work with in systems, just what happens from the source to the output. No, that's true, but what about feedback? So we introduced feedback, and we developed the equations to model the feedback, and lo and behold, those equations produced more possibilities for poles that provide instabilities in the system. If those of you in engineering that can appreciate systems are here, you'll recognize that this denominator of this transfer function, when it goes to 0, it produces infinities. We want to know where those infinities are and why they occur. What volume can you turn the PA system up to before they start to affect you? So we use diagrams, pole 0 diagrams, and again, I try to make these as neat and simple as possible, as uncluttered as possible. Every page, for the most part, uses its real estate as efficiently as I can. I don't have places on the slide where I can add anything else. I have only the points that are relevant, and I try to balance the slide. That balancing of the slide, I think, is important. It draws people in. When a slide is unbalanced, there's something subconscious that almost goes off in the head that says, something's funny about this slide. It's just not professional. Same thing that happens when you're at a movie and you're watching, a new movie that comes out. If the editor goofed somehow, you notice it. It takes your attention away from the movie. That's the one thing I don't want, is people's attention taken away because of something on the slide that's unbalanced. Misspelled words do that too. So I am a stickler about proper spelling, proper grammar. Okay, so here we went all the way through and we have this nice little plot. And let's see, I think this is, yeah, here we have more plots. I want to show you the movie that I generated though. And to try to bring this to life, what I showed is what happens when you've got the volume increasingly turned up. And as it would happen, today I'm playing this on a new computer and the PowerPoint animation doesn't play. So I have to apologize to all of you. And this is a lesson for you as well. Make sure that when you move to a new computer, that all of your graphics are available to be picked up and played. Oh well. My finale here is something I can't present. But I will go back to this graph and show you here's what happens as the volume is turned up. What we have is all of these poles appear in the transfer function. They introduce oscillations that occur at all of these various frequencies. That's what causes acoustic howl. And in fact, what we've got here is a threshold that tells the technician just how low you need to turn the volume down. Okay, well, with my apologies about not having the animation to be able to present, I'll continue on here and we'll end our lecture. I always end it by talking about what we're going to talk about next. We're going to talk about now concepts that immediately follow on from the previous lecture. Okay, there it is. I'm going to end real soon here. In summary, what are the key technical attributes of this slide set that I try to strive for? Well, text, Times New Roman, one font only, no misspellings. There should be an S right here. I notice that when I'm doing my lecture. The math, all in italics. No more than 2 colors for the text. Microsoft gives us thousands of combinations of fonts and colors. You know what? You don't want any more than about 2 of them. Clear graphic titles, axes, and labels. Use of all of the slide real estate, all the area. Balance the material on the slide. Simple titles that connect ideas up on the top of the page. Cartoons. No more complexity than needed in the cartoon. Use equations as a language. We shouldn't be afraid to do that in engineering. I certainly wouldn't do that if I was teaching a humanities course, but in engineering, we shouldn't be afraid to do that. An intro slide, an administration slide, last lecture, this lecture, next lecture slides. Tie this lecture, in other words, together with all the other ones. Topic separation slides as well. For a 50-minute lecture, I'd have no more than about 20 of these, what I call complex slides. They can be punctuated by the transition slides. They can include, for example, that motivating slide at the beginning that's kind of soft. But as far as the real deep slides, you'll need to spend typically about 2 minutes minimum on each one. And so never more than about 20 really in-depth slides per 50-minute lecture. The preparation time to make these slides from your existing course notes is about 15 to 20 minutes per slide on the average if you're not bringing in any new material. If you're bringing in new material, if you're coming up with a brand new whiz-bang graphic, like that one I tried to show you, you might spend almost your whole Saturday getting it just right. That's an investment. And if you do it for a good reason, for making the course complete, you'll use it sometime or another in the future. Strive for consistency, consistency, consistency. Is it something that you can ever really reach? No, but this is what you got to strive for. It's worth it. I'm just going to end by talking about the online studio and what I think is important in the online studio. This is the top 10 list. I'll again try to see who's old here. We'll show our age. Anybody know who that guy is? Okay. Not that old.
Hey,
Top 10 things to consider when setting up a home studio for remote instruction. Number 1 is a quiet area closed to foot traffic, kids, pets, leaf blower noise, etc. Number 2 is a comfortable seat and an uncluttered desk. You don't want all your other attributes of your daily existence to invade your lecture space. So that research paper that you were working on earlier, clear it off your desk. You don't want it there. You just want a nice uncluttered desk so you can focus on the lecture. Rolling seats are good, I found out, because you like to kind of move around a little bit. It keeps the body moving, keeps the blood flowing. Diffuse lighting, number 3. Using one of these warm colored ring lights is really worthwhile. These ring lights are like $50 or so. A reliable wide bandwidth internet connection. Wired is better than wireless, but if you got to go wireless, and most of us do, then make sure your router is close by and make sure that the rest of your family is not all using your router during the time of your lecture, etc. An uninterruptible power supply for your PC and lights, etc. Something in the neighborhood of 500, 800 watts. Most likely sometime during the semester, if you're giving 40, 45 lectures, there's going to be an electrical storm and the power might go out. The last thing you want is your activity being shut down. So good insurance. If you have a good machine, a high quality machine, it's going to be able to pick out the background and key on it, and you can put out these nice backgrounds like this background I have over here. That's a picture of my cluttered bookshelf in my office. I'm not in my office, but it looks like I am. If you have an older machine, using a green screen, literally a green cloth helps, and you can purchase these green cloths for about $25 or so. Don't buy anything other than a real green screen if you're going to use one, though. They have a certain kind of a fluorescent color green on them. A good quality web camera helps. I'm not using one today, but in my studio I'm putting together, I'm going to be picking up a Logitech camera. The laptop cameras are also not bad. A good microphone helps. I'm not using one today, but they do make a difference. And the Yeti microphone is one I've got, and I'm integrating that into my studio. I'm not using a tablet, but I do have an overhead camera that looks down on the desk that allows me to switch to it and be able to scribble equations, draw diagrams on a piece of paper. Something that you can use in real time is worthwhile. I happen to like using a pencil and paper because I've got all the precision and all the degrees of freedom in the world. Finally, a GPS synchronized clock is very handy. Here's the one I used. It's an app on my cell phone, and it's got good old dials on it. Those dials are really easy to look at, glance at. I don't have to read digits. And it's got a second hand on it. So as a second hand sweeps up to the top of the hour, I can start the course right on time. think the foremost thing is you want an uninterrupted, high fidelity presence with your students for the entire period of the class. That's our top 10 list. Well, here's a few more. They're minor. A few more things to consider when setting up a home studio for remote instruction. If your room reverberates, you might want to put acoustic tiles in the room. Another easy way of doing this is put your clothes hung on hangers all over the room. They tend to damp the acoustic reverberations. Or here's another little trick. The acoustic pressure points are highest in the corners of the room. And so even take a filled basket of laundry and put it in the corners of the room. That helps a little bit. A checklist to refer to before the start of each lecture. I'll show you mine in the last slide coming up. A comb and a small mirror. We've got to at least pretend to be TV stars. And as you're running around before your lecture, it's likely that you want to at least take a quick look at yourself to make sure you're presentable. A course notebook and pencil, so that for the duration of your course, you have some single one place where you can be jotting down notes if they come up during your lecture. You don't want to take your attention away from the lecture, but nonetheless, having a place where you can quickly jot down a note, sometimes that helps. Otherwise, at the end of the lecture, sometimes you'll forget about all the things that you saw in your lecture that you want to remember. A spill-proof place for your coffee or tea is important. The only thing worse than having a spilled cup of coffee in the morning is a spilled cup of coffee on your keyboard. A space heater in case the room temperature fluctuates. Throughout the lecture, maybe the heater's kicking on or off in your house during the winter. It's nice to have the ability just to reach down, dial it up or down. You should be comfortable during your lecture. If you're not comfortable, it's going to somehow come across to your students too, I think. It looks like we'll be using home studios for the foreseeable future. I think it's a good investment. Here's my last slide. Look at that backdrop. I got David Letterman's backdrop there. The checklist. 15 minutes before, disconnect any phones you have in the room. You don't want them ringing during your lecture. Check your internet connection. Make sure it's operating properly, that you got all the bars you need. Check your microphone audio, do a mic check. Adjust the backdrop. Turn on your lights and adjust them to, this is all been about 15 minutes beforehand. Open your clock amp, put your phone on silent, comb your hair. Start your Zoom video recording 30 seconds before. I just always do a countdown. I watch the second hand. And start your audio and your video about 15 seconds before. That allows you to go right in to your first slide where you introduce the lecture. After the lecture, what I always do is at the end is I entertain any questions out to about 15 minutes after the lecture period. There are always students who have questions. I ask that they be saved until the end. I ask that they jot them down and save them. Most of my students do. Taking questions during the lecture really does throw your train of thought. Some people can do it, I can't. Correct any slide errors as soon as possible. That one little spelling error I showed you earlier before, that animation that didn't come up, correct it as soon as you can. Republish your final corrected slides onto Canvas as soon as you can, get it over and done with. Download your Zoom video to Canvas so that the students who couldn't make your Zoom lecture are able to make it. And that is pretty much the bottom of my well of tips. I always end by saying thanks, stay safe, and best wishes for the fall semester. Be happy to take any questions if you have any.
Al, thank you so much. That was wonderful. So I want to turn things over to the audience, but I just want to reflect. What I took from that was congruent with your opening about symphonic composition. And what I took from that, in essence, is that structure is liberating. That by mapping a structure for teaching, and then in the end, a structure for remote organization, you find the liberation of clarity. And I think that's masterful. It's a masterful observation, because without structure, we are unable to get to clarity, and then we are unable to get, I think, to extending towards improvisation, which is when you have your students engage. So I have a question that I want to get to, but I wanted to turn to the audience and get some feedback and some thoughts about what you presented. So, discussants, questions. Jem, go ahead.
Hi, thanks Al for that talk. That was great. I had a few questions, but I'm distracted by the thought that you were distracted by my hair in all of our meetings because it is the wildest, most knotted hair and is held up with a green screen clip right now. And now I've learned my lesson. So the first question I had was, were you using the Yeti mic for this talk?
No, I wasn't. And normally I as of this summer, since I bought one, I am. I'm right now finishing my studio. The studio has been a summer-long project. I began using it in the spring, almost immediately when the pandemic hit. And it was in kind of a ramshackle shape. So the whole summer has been in building it up and turning it into something that's a little more reliable. So not yet, but I will be.
The reason I asked was I had a follow-up question about positioning because yeah, I have a Yeti mic as well, but I haven't been able to make it sound good, although everyone says it's great. And I think positioning is really key.
Yeah.
The other thing I wanted to ask was your animation, if it had played, do you know if it's playing well over Zoom? I guess it depends on people's connections.
Yeah, that's an interesting point. It's not a very, what you'd call, informationally complex animation. In other words, frankly, there's probably a lot more going on in the scene right now with me waving my hands from an informational standpoint than that animation goes. So I don't usually use animations that have so much information content that they would stress the bandwidth. And I always will also play the animation and I'll simply have it repeat. And I will play it at least 3 times, and then I'll have it pause, and then I'll talk about it, and then I'll usually play it another 3 times so that everybody either gets sick of it and bored with it and wants to see the next slide. You know what I mean? You
Yeah.
really got to get it across, but just at the right level. And you certainly don't want to bore people either.
And my final question, and I think I know the answer to it already. You don't do a lot of fancy transitions, which I think is good. I think that's too many bells and whistles. But I wonder why you're not using Beamer so you don't have to move all your LaTeX equations over. And I'm guessing it's because you really want to position everything just so, and it's harder to do. So.
Absolutely. I want control of my machines. And this is another part of my philosophy that we could probably have a whole other lecture on, and I won't bore you with. But I believe these little pieces of silicon that flip and flop were meant to serve us, not we meant to serve them, not we meant to somehow have to be forced into the little box of capabilities that they provide us. So I'm constantly striving to maintain my authority over the machine, and it's more and more difficult every year. But in this regard, using LaTeX and having the equation printed and then allowing me to stretch it and shrink it and cut it and paste it, that gives me more capability than sitting there trying to second guess what some app will allow me to do when I press some key. I've never again been in any way satisfied with the Microsoft equation editor.
Oh, I know. Well, I really liked your slides. Before you even mentioned it, I just felt there was a good sense of balance in them, and they were really clear and popping. And thank you. That's all I have.
You're welcome. Mm-hmm.
Great. Other thoughts, other questions? Leyland, you're muted if you're coming up with something.
Leland here, and I'm muted. Thank you, Al. That was great, and I like the idea of not letting the software run you. I'm having some troubles with that right now. But when you were saying that the slides, a good slide will take a certain number of minutes. I don't use equations, so I do my slides. I make all the text in PowerPoint, no, in, pardon me, Microsoft, in an outline, and then I transfer that all at once. I was teaching a course on the history of medicine once, and I routinely didn't have enough time to prepare, and I was able to create 25 slide PowerPoints in half an hour because I had the bank of photos and I had the bank of text, and man, yeah. But I agree that a simple template is a good one, and I think it's very helpful for the students in your case, especially with the fonts that are directed to a particular task. I think that's really helpful for students to keep it all straight.
You know, in terms of producing the slides, I think on my best day, I might have been able to knock out a lecture and be happy with it in 2 hours. On my worst day, it probably took me more than a full working day to do. But there's also kind of a stride you hit. The first lecture in a course is never usually one you really want to brag about. It's always a little rough around the edges. You tend to hit your stride in the middle of the semester, where you get this momentum going, and you know if your course is Monday, Wednesday, Friday, that means every Sunday, Tuesday, and Thursday you're going to be intellectually busy. But you hit this stride, and you really can get efficient after a while. Then as you get toward the end of the semester, you and all the students, of course, are looking for that light at the end of the tunnel, and that's when you've got to give it that little bit of extra effort if you really want the whole thing to come through proper. But it's a good investment. It really is an investment.
About the light at the end of the tunnel, this past spring, I was using PowerPoints. I have sort of more bulleted discussion points is what was on the PowerPoints, but I had the same color background, but it got lighter and lighter as we got closer to the end of the semester. And I asked the students if they had noticed anything, and they didn't, except when I told them, and then they said, oh yeah, that's right. So we started with hunter green, and we got to kind of spring green, and in another class it was sort of navy blue, and we got to sky blue, and they liked that a lot.
So,
yeah, that's a neat technique. I never thought about that.
So I want to ask a question here, Al, as we're closing up. How do you differentiate between remote teaching and online teaching? Because it strikes me that one of the insights here is that ultimately you're delivering this in a remote Zoom environment, but by recording it and refining it to the point you have, you're essentially developing online materials that could be delivered just as well, almost asynchronously. So I wonder if you would talk about that for the, well, we're over time already, but just a minute or two.
You know, I was wondering how I should even title this lecture, whether it should be titled Online Learning or Remote Learning. And I don't know if there is much of a difference. Furthermore, I will also state that I think if you have a successful semester in putting slides together for a course, you've got now the video material that becomes the content for a MOOC, sitting there waiting to be edited and turned into a MOOC. So again, I look at this as an investment, really. A well thought out, structured course, and I like your idea of how structure is liberating. I never thought of that. That's an interesting phrase. But in our business, I think structure is liberating. But a well thought out course where you put that effort in, you can turn that into other things as well, a MOOC, for instance. The other thing I found out is in my graduate courses, I reuse these slides over and over and over in popping up concepts that I need to talk to my graduate students about for research purposes. Long after the course is over, long after they've taken the course, the slides just pop back up and we're able to use them again. So yeah, it's an investment.
It's excellent. And I took really 4 big points from this, and I'm just going to wade in here and summarize. The first is that structure is liberating. What you've been talking about is developing a structure that spans all your courses, literally spans all your slide decks, but that you can then reutilize to make new slide decks or make new courses. There's a structural paradigm here which liberates you to achieve clarity. The second point that I wanted to take here is that there's an interweaving, I thought that was beautifully said, about how, like a symphony, there's themes that you interweave within the deck and then across the course. And it struck me that though your teaching modality appears very linear, that linear is essentially recursive as well, because you're always returning. And that combination struck me as very powerful. A third point connected to both of these, recursion seems like a complexity, but in fact, it strikes me that your structure is always pushing towards simplification, and that in using PowerPoint exclusively almost, you're pushing towards simplifying your structure. I thought that was elegant. Lastly, I really saw you bringing distance and asynchronous together. And that allows you to make, essentially, at some point, you're going to make one best course that you can deliver in an asynchronous environment.
That'll be my 9th.
It's great. So I want to thank you. Thank everyone
You're
here for
welcome.
coming. But I thought, Al, that was a model of a kind of clarity that we would all do well to study deeply. Thank you. Thank you. Wonderful work.
You're welcome. Mhm.
Thank you, everyone, for coming. Onwards.